Hey students, this is lesson 5-6. In this lesson we're going to learn how to determine whether lines are parallel, perpendicular, or neither by looking at their equations and to write equations of parallel and perpendicular lines. Go ahead and do the review here, some important stuff that you're going to use for this lesson. All right, slopes of parallel lines. This one should be rather common sense. Non-vertical lines are parallel if they have the same slope. So in order for lines to not intersect, they have to have the same slope and different y-intercepts or x-intercepts, however you want to look at that. So draw a line from each equation of column A to the equation whose graph is parallel in column B. Now remember, not all vertical lines will be parallel and all horizontal lines will be parallel. So what is the equation in slope-intercept form of a line that passes through the point 215 and is parallel? Well, to be parallel, it has to have the same slope. So we know our slope is going to be 4. So we're going to just start writing this equation. Y equals 4x plus whatever the y-intercept of this new line would be. And to get it to pass through this point, that means that pair of numbers has to be a solution. So if I substitute 15 for y and 2 for x and then add b, it should be true. And 4 times 2 is 8. Subtracting 8 from both sides, we get b is 7. So my equation is y equals, we need the same slope, so 4x plus I need this new y-intercept, 7. All right, you try that. All right, another concept here, slopes of perpendicular lines. I'm going to do a quick, just a little graph showing you some different lines so we can kind of discover what the deal is with slopes of perpendicular lines. All right, so I got a couple lines here, and just to show you that they're parallel, I'll just put in a square here. You can see that they're, perpendicular, sorry about that. So I'm going to use this to show that these two lines right here are perpendicular, and the way I'll get that is by just putting that right angle right in there, so you can see those two are perpendicular, and also these two are perpendicular. Okay, I can show you that. I'm doing this, line that up there, and notice that that fits in there real nicely. So those two are perpendicular. Now let's look at their slopes real quick here. So this slope is 5 down 2 over 5 down 2. And that slope is negative 2/5. This slope is up 5 over 2. And you can see that again here, up 5 over 2. So that slope is 5 over 2. Notice that one is positive, one is negative, and other than that, they're reciprocals of each other. So we say they're opposite reciprocals. Let's see if that holds true here. This slope right here is over 6 down 1. That slope would be negative 1/6. And then this slope is up 6 over 1. So that would be 6 over 1. So it holds true again. So we see that the slopes of perpendicular lines are opposite reciprocals. So, and that's what this is showing here. And you can always tell opposite reciprocals because the product of the two numbers will be 1. So the slope of a line is 2. What is the slope of the line perpendicular to that line? So 2 can be written as 2 over 1. So think of flipping that over and making 1 negative. And then if you multiply those two, you should get negative 1. That would be your check. All right. So let's check this out and see if we think these are the graphs of 2y equals negative 3x plus 6 and y equals 2/3 x plus 2 parallel, perpendicular, or neither? All right, to figure that out, we're going to use the slopes. So check, we know that this slope, since it's written in slope-intercept form, is 2/3. So the slope of this line is 2/3. Okay, and since that one's already written in slope-intercept form, let's go ahead and transform this into slope-intercept form. And all we need to do that is get rid of this 2 here. And the way we would do that is divide both sides by 2, or multiply both sides by 1/2, however you want to look at that. And if we did that, we would get half of -3, which is -3/2. And half of 6 is 3. Okay, now we can see the slope here is -3/2. And obviously they're not the same number, but are they opposite reciprocals? The way to check is just to multiply 2 times -3 is -6, 3 times 2 is 6. And when you divide that, you get -1. So yes, they are opposite reciprocals. So these lines are perpendicular. All right, you try that. All right, to write an equation of a perpendicular line, what we need to do is figure out what the slope is of the line we want to be perpendicular to, and then just write the equation using that slope and the point that it goes through. So, and I think we can use point slope here if we want also. We're just going to have to convert it into slope-intercept, which is what all these answers are. So, so our slope of our original line is -5, 6. So we need the opposite reciprocal. So let's say the slope of our perpendicular line is, flip it over and make it positive. So we need 6/5. So let's eliminate A and B right now. Now what we could do is just check which of those last 2 equations has the solution 10, 15, but we need to be able to do a little bit more than that. So let's just write out the equation. Y minus 15 is equal to 6/5 times x minus n. And then we'll just put that into standard form, or into slope-intercept form, by using the distributive property. 6/5 times 10 is 12. So we get this, and then we'll just add 15 to both sides. And we get y equals 6/5 x plus 3. So our choice is C. All right, you try that. All right, so we're going to solve a problem using this idea. Carl is using coordinate grids to make a map of her hometown. She plots Main Street as shown. If 3rd Street is perpendicular to Main Street at 5, 7, what is the equation for 3rd Street? So we need to know the slope of Main Street in order to write the equation of the line that's perpendicular. So let's just use the grid to figure that out. It looks like we have a run of 5 and -1 is our rise. So the slope of Main Street is equal to -1/5. So the slope of 3rd Street, let's just put 3rd, is equal to the opposite reciprocal of that, which is 5/1, or just 5. So we're going to use 5, and for our equation, we're going to use point slope form. So y minus y1 equals m times quantity x minus x1. And we needed to go through this point, 5, 7, so we'll do y minus 7 is equal to 5 times x minus 5. And if we had to simplify that a little bit, which isn't a bad idea, we would just use the distributive property and multiply that out, and then add 7 to both sides, and we get y equals 5x minus 18. That would be a very simple equation for that. All right, you try that. All right, that's it for today. Go ahead and do the lesson check, and we'll talk about it next time we meet in class.